Imagine you have a building, a massive one, let's say the Eiffel Tower. Now, imagine taking that 330-meter iron icon, laying it on its side, and pushing it into the Atlantic. Most sane people would expect a splash and a very expensive salvage mission. But in the world of modern naval engineering, we don't call that a disaster, we call it Tuesday. We are entering the era of the floating skyscraper. The largest cruise ships today, like Royal Caribbean's Icon class, are longer than the Eiffel Tower is tall and weigh over 250,000 tons. To put that in perspective, that's about 6,000 city buses or a small mountain of steel. But here is the part that should keep you up at night. While these monsters tower 20 stories above the waves, their draft, the part actually under the water, is only about 9 to 10 meters. That is less than the height of a 3-story house. A 20-story building held up by a 3-story basement in a literal hurricane? It's going to tip. It has to. Physics says no. Ah, but does it? Why does a ship stay upright? Is it because it's light? 250,000 tons isn't light. Exactly. So if the weight doesn't make it sink and the height should make it tip, what are we missing? The secret lies in the center of gravity. You see, while the top of the ship looks like a bloated wedding cake made of glass and marble, the guts, the engines, the fuel tanks, and the massive water ballast systems are all packed into that tiny 9-meter basement. It's like a lead-weighted bobber. The heavier the bottom, the more the top can pretend gravity doesn't exist. If you think the Titanic was the peak of maritime scale, I have bad news for your nostalgia. The Titanic would look like a tugboat next to these modern giants. We are talking about vessels that are roughly 5 times larger in volume. In the early 1900s, shipyards were building what we'd call Chevrolets of the sea. Reliable, functional, but basic. Today, we are building Rolls-Royces. We are talking about 500 glittering chandeliers, acres of marble, and enough gold leaf to make a pharaoh blush. But here's the kicker. Luxury is heavy. Every time a designer adds a marble floor to a penthouse suite on the 17th deck, an engineer in Italy has a minor heart attack. Why? Because weight high up is the enemy of stability. This isn't just a battle against physics, it's a battle against the most terrifying force of all, the contract. These ships take about 4 years to research and build, requiring over 6 million hours of labor. But the deadline is absolute. In this industry, shipyards are under continuous pressure. If the liner is not delivered on the exact day promised, the penalties are, and I'm using the technical term here, absolutely exorbitant. We are talking about penalties of over 100,000 euros per day for every day the ship is late. When you're dealing with a 600 million euro project, there is no "oops, we forgot the propellers." We need to stop calling these things ships. They are sovereign, self-sufficient cities. At any given moment, a megaship can be carrying up to 10,000 people, 7,000 passengers, and 3,000 crew members. To keep that many people alive and happy in the middle of the ocean, you need more than just a big engine. You need a metabolism. These ships produce 3 million liters of drinking water every single day from the sea. They have their own power plants, their own sewage treatment that produces water cleaner than what comes out of your tap, and, because humans are humans, their own legal systems. Because below the Lido deck in the Constellation Theater lies a world passengers never see. By law, every large cruise ship must be prepared for the full spectrum of the human experience. That includes a functional morgue that can hold anywhere from 2 to 10 bodies. When you have 10,000 people, mostly elderly, spending weeks on board, nature occasionally takes its course. And for those who enjoy the open bar a bit too much or decide to commit a crime in international waters, there is a brig, a shipboard prison. You aren't just on a vacation, You're in a floating municipality with its own police force, its own jail, and its own cemetery. So we have a city the size of a skyscraper that refuses to tip over, manages its own debt, and pays a small fortune if it's a minute late. But how do you actually build a 300,000-piece puzzle where every piece weighs as much as an elephant? And how do you steer something that heavy through a narrow port without accidentally wiping a small Italian village off the map? The answer involves building the ship upside down, using Fatunanove liquid metal to find invisible cracks, and engines that can spin 360 degrees like a ballerina. But to understand the mega block revolution, we have to go to a shipyard in France where robots cut steel underwater to prevent it from screaming. So, the next time you see a tiny white speck on the horizon, don't just see a boat. Remember that you're looking at one of the most complex machines ever built by human hands. It's a city that breathes air bubbles to stay slippery, a skyscraper that dances on a 9-meter keel, and a miracle of engineering that essentially refuses to obey the laws of common sense. We've seen how they're built from Lego blocks, how they turn on a dime using Azapods, and how they turn trash into fuel. We started this journey asking how something this big doesn't just sink. The answer isn't just physics, it's meticulous, obsessive attention to detail. From the 5mm precision of a hull joint to the way a captain steers into a collision to avoid it. These ships are a testament to what happens when we decide that impossible is just a suggestion in a contract. Which fact surprised you more? That your luxury cruise has a legally mandated morgue, or that there's a prison cell right under your favorite buffet? Write Team Morgue or Team Brig below. I really want to see which side of ship life fascinates you more. In the old days, you built a ship like a house. You laid the keel, then you stacked ribs and plates on top, piece by piece, while everyone prayed it wouldn't rain. But building a 250,000-ton monster like that today would take approximately forever. Today, these ships are built as a mega block puzzle. We're talking about 300,000 individual steel parts that have to fit together with the precision of a Swiss watch, but at the scale of a mountain. 300,000 pieces? I can't even finish a 500-piece puzzle of a lighthouse without losing a corner piece. Well, if the engineers lose a piece here, they don't just look under the sofa. They lose a €600 million investment. It all starts in a giant bath. And no, this isn't for the crew. This is where the ship is born. To get those 300,000 pieces, you need to cut steel plates that are up to 20 meters long. But there's a problem. If you cut heavy steel with a normal torch in the open air, the heat causes the metal to warp and distort. And when your margin of error is 1/10 of a millimeter, a little wiggle in the steel is a disaster. So, engineers use computer-controlled plasma cutters that work entirely underwater. The machine fires a jet of superheated gas, plasma, at the steel. Because it's underwater, the surrounding liquid acts as a massive heat sink, cooling the metal instantly so it stays perfectly flat and dimensionally stable. It's essentially a 30,000-degree lightsaber working in a swimming pool. Once the pieces are cut, we assemble them into blocks. But we don't build them upright, we build them upside down. Is that to make the fish feel more at home? Not quite. It's for the humans. Inside a single deck, you have to run over 1,500 kilometers or 930 miles of electrical cables, ventilation ducts, and plumbing. If you built the deck normally, workers would have to spend months with their arms over their heads, welding pipes and pulling wires into the ceiling. It's slow, it's exhausting, and it leads to mistakes. So, engineers flip the entire deck upside down. They lay all the heavy machinery, pipes, and 1,500 kilometers or 930 miles of cables on the floor, which is actually the ceiling. And then, once everything is bolted down, a giant crane flips the whole 1,000-ton block right side up. It's ergonomics on a Titan scale. But how do you make sure the ship doesn't split in half when a 30-meter wave hits it? You weld. A lot. We're talking millions of hours of welding. But steel is a temperamental beast. When it heats up and cools down during welding, it can create microscopic cracks you can't see with the naked eye, but that the ocean's pressure will find instantly. To catch these invisible killers, engineers use a technique that looks like alchemy. They use a special liquid metal, a sort of metallic superglue, that is designed to have a very low surface tension. They pour it over the seams, and if there is even a microscopic fissure deep inside the weld, the liquid metal will sink into the crack, revealing exactly where the structural weakness is. If the metal stays on the surface, the weld is a fortress. If it disappears, you start over. Because out there in the Atlantic, there is no plan B. To put this puzzle together, you need a monster. Meet the TGP Gantry crane. It's the strongest lifting machine in Europe, standing 100 meters tall and weighing more than 10 Airbus A380s. It can pick up a 1,200-ton block, that's about 200 elephants, and move it with a precision of 5 millimeters. If the blocks are off by more than that, the pipes won't line up, the I-95 corridor will be crooked, and the ship becomes a very expensive piece of scrap metal. It takes 1,500 workers 9 months just to get the structure to look like a ship. But a ship that can't move is just a very heavy hotel. To truly conquer the ocean, we need the heart of the beast. Coming up, we're going under the hull to see the engines that don't need a rudder, can spin 360 degrees like a ballerina, and pack the power of 7,000 washing machines. It's time to talk about the Azapod revolution. Now that we've built our floating skyscraper, we have a slight problem. It's heavy, really heavy. 250,000 tons of inertia that, according to the laws of physics, would very much like to stay exactly where it is. So let me ask you, if you had to move a city across an ocean at 40 kilometers per hour, what would you use for an engine? A jet turbine? 1,000 rowing oars? The answer is actually hiding under the stern in these massive alien-looking pods called Azapods. And when I say massive, I mean it. A single one of these units can weigh as much as an Airbus A380. But the real magic isn't the weight, it's the raw, unadulterated power. A single main electric motor inside an Azapod produces 20 million watts of power. To put that in terms your brain can actually process, that's the equivalent power of 7,000 washing machines all running at the exact same time. Now here's a challenge for you. Imagine you're the captain. You've just arrived in a narrow harbor in the Mediterranean. You have 300 meters of steel behind you and a historical landmark 10 meters in front of you. How do you park this thing? In the old days, you'd need 4 tugboats, a dozen ropes, and a lot of sweating. But today, you use a joystick. These ships have no rudders, no giant slab of metal at the back to steer. Instead, the entire Azapod unit, propeller and all, can rotate 360 degrees around its vertical axis. This means the captain can point the full thrust of those 7,000 washing machines in any direction. By twisting a small joystick on the bridge wing, the captain can make this 250,000-ton monster move sideways, spin on a dime, or perform a crash stop in a distance that seems to defy the laws of momentum. It is essentially a high-stakes game of Dance Dance Revolution, but if you miss a step, you accidentally delete a small Italian village. But wait, you might say. Surely spinning a giant metal fan that fast must be loud. You're right, and in the luxury cruise business, noise is the enemy. This brings us to the propeller designer's worst nightmare, cavitation. When a propeller spins too fast, it creates areas of such low pressure that the water literally boils at room temperature, forming vacuum bubbles. This sounds cool, but it's a catastrophe. When those bubbles burst, they collapse in microseconds, sending powerful shock waves through the water and into the hull. It feels like someone is hitting the bottom of the ship with a 10-ton sledgehammer, thousands of times per second. If engineers don't get the shape of the blades perfect within a fraction of an inch, those shock waves will vibrate the champagne right out of the glasses in the VIP suites 15 decks above. This is why these propellers are cast from a special bronze alloy in a single 3-minute continuous pour that takes 3 weeks to cool down. Because down here, one tiny bubble can ruin a €10,000 a night vacation. And then there's the nose. Look at the front of the ship. See that weird bulbous growth under the waterline? That's the bulbous bow. It looks like a mistake, but it's a masterpiece of hydrodynamics. Normally, the front of a ship pushes a massive wave that acts like a wall, slowing the ship down. But the bulb creates its own wave that perfectly cancels out the first one. This wave cancellation reduces water resistance by up to 20%. That's not just for speed, it saves hundreds of thousands of euros in fuel every single year. So we have a skyscraper that can move sideways, breathes bubbles to stay quiet, and has a nose that deletes waves. But how do you keep all this machinery stable when 5,000 people decide to all run to the port side at once to see a dolphin? To solve that, we have to look at the battle between marble floors and the center of gravity. We've built the hull and given it a heart of 7,000 washing machines. But now we face a problem that has literally killed people in the past: top heaviness. You see, the people paying $10,000 for a suite don't want to sleep in the 9-meter basement next to the vibrating engines. They want to be on the 20th floor, surrounded by marble, glass, and 500 glittering chandeliers. Let me ask you a question. If you stack 20 stories of luxury on top of a base that's only 10 meters deep, what happens when a gust of wind hits it? Or worse, what happens when 1,000 passengers all run to the left because someone spotted a dolphin? If you guessed a very expensive somersault, you're right. In 1915, the SS Eastland capsized right in the Chicago River because it was too top-heavy. To avoid the rubber ducky of doom scenario, engineers have to count every single gram. I'm not joking. They maintain an inventory of over 20,000 items on board, from lifeboats to individual champagne bottles, and a computer tracks exactly where each one sits to calculate stability. But the real genius is in the walls. In those ultra-luxury suites at the top of the ship, the walls look like solid, heavy marble. But if they actually were solid stone, the ship would have the center of gravity of a spinning top. Instead, designers use a honeycomb system. They take a slab of marble and slice it until it's only 1 millimeter thick. Then, they bond that tiny wafer of stone onto an aluminum honeycomb structure. It looks like a Roman temple. It feels like luxury, but it weighs less than a piece of plywood. It's a beautiful engineering lie. If we used real stone, we wouldn't be sailing, we'd be sinking with style. Now, consider this. Even with light walls, the ocean is a chaotic mess. If the ship rolls more than a few degrees, the soup starts flying, the grand pianos start rolling, and the passengers start demanding refunds. How do you keep a 250,000-ton building perfectly level in a 5-meter swell? You give the ship wings. Hiding under the waterline are active retractable stabilizers. These aren't just little fins. We are talking about structures 17 meters long, roughly the size of a private jet's wing. Using giant gyroscopes and high-speed computers, these wings detect the ship's tilt in milliseconds and tilt themselves to create counterpressure. They can eliminate up to 90% of the ship's roll. Perfection. Though, a word of advice, don't try to use these wings when you're docking. At speeds under 10 knots, they're useless and will probably just take out a pier. But wait, there's one more variable: you. Humans are unpredictable. Imagine it's a beautiful sunset and the captain announces there are whales on the port side. Suddenly, 5,000 people, that's roughly 400 tons of meat and bone, all run to one side of the ship at the exact same time. This would cause the ship to tilt instantly. To stop this, the ship has a metabolism of water. A dedicated computerized ballast system monitors the ship's tilt constantly. The moment it feels those 5,000 whale watchers move, high-speed pumps move hundreds of tons of seawater between interconnected tanks in the basement to compensate. The ship effectively leans into the weight of the crowd before they even realize they're tilting it. It's a silent, invisible dance happening 24/7 beneath your feet. So we have a ship that stays level by lying about its marble walls and dancing with its ballast water. But how do you sustain a city of 10,000 people in the middle of a saltwater desert? Where does the fresh water come from? And more importantly, where does all the stuff go after dinner? Coming up, the secret metabolism of the Icon class, where trash is turned into fuel and the sea is boiled for free. We have spent in the previous parts of the video marveling at how this floating skyscraper stays upright and how it dances through narrow ports. But now, we need to address a much more human problem. Think about your own home for a second. You have a pipe for water coming in, a wire for electricity, and a pipe for, well, the things we don't talk about at dinner parties, going out. Now imagine cutting all those lines, putting your house on a raft, and pushing it 500 miles away from the nearest coast. How long before the lights go out? How long before you're thirsty? A modern megaship like the Icon of the Seas is essentially a sovereign state with a population of 10,000 people. That is more people than many towns in rural England or the American Midwest. To keep that many humans alive, clean, and entertained in the middle of a saltwater desert, the ship needs a metabolism. It needs to breathe, it needs to drink, and most importantly, it needs to deal with the 8 tons of garbage those 10,000 people produce every single day. Today, we're looking at the secret engineering that turns a cruise ship into a closed-loop ecosystem that would make a Martian colonist jealous. Let's start with the most basic requirement for life: water. A city of 10,000 uses a staggering 3 million liters of fresh water every single day. Carrying that much weight from the port would be an engineering nightmare. Water is heavy, and every ton of it is a ton of fuel wasted. So here's a question for you. If you're surrounded by billions of gallons of water, but it's all full of salt, how do you get a drink? The answer is that the ship's engines are actually giant unintentional kettles. Modern ships produce nearly all their drinking water by boiling the ocean using waste heat. You see, a diesel engine is only about 50% efficient. The rest of that energy is lost as heat. Instead of just blowing that heat out of the chimney, engineers wrap the engines in heat exchangers. They pump in cold seawater and use that free engine heat to flash boil it in a vacuum. From every 100 liters of salty seawater, the ship extracts 30 liters of pure distilled water. This water is so clean it's actually dead. It has no minerals and would taste like a laboratory. So the ship has its own mineralization plant to add back the taste of fresh spring water. It is a thermodynamic masterstroke. The very act of moving the ship through the water provides the energy needed to keep everyone hydrated. And for the days when the ship is docked and the main engines are off, they have a backup system called reverse osmosis, which uses high-pressure membranes to literally squeeze the salt out of the water at a molecular level. A process that is 65% more efficient today than it was just a decade ago. But the ocean isn't just a source of water, it's also a wall of resistance. Friction is the silent killer of efficiency. To push 250,000 tons of steel through the water, you have to overcome the grip that the water has on the hull. Now, try this mental experiment. Imagine trying to slide a heavy cardboard box across a wet concrete floor. It sticks, right? Now imagine someone blowing a constant layer of air bubbles under that box. Suddenly, it glides. The newest generation of ships literally sails on a blanket of bubbles. This technology, called air lubrication, uses compressors at the bow to blow millions of microscopic bubbles underneath the flat part of the hull. This creates a thin layer of air that acts like a carpet of ball bearings. Because air is much less dense than water, the hull no longer rubs against the ocean, it slides over the air. This isn't just some experimental gimmick. By reducing the drag, this system saves up to 15% of the ship's total fuel consumption. In an industry where fuel is measured in hundreds of thousands of euros per trip, a few bubbles are the difference between a profit and a loss. Think about the irony here. We use the most advanced steel in the world, and the best way to make it faster is to stop it from actually touching the water. Finally, we have to talk about the output. 10,000 people produce a mountain of solid waste and sewage. In the old days, and I mean the really old days, the solution was over the side. Today, doing that would result in a legal and environmental execution of the company. So what do you do with 8 tons of garbage when you're in the middle of a protected marine sanctuary? On the newest ships, you don't throw it away, you use it. The Icon class uses a technology called microwave-assisted pyrolysis to turn waste into fuel. This isn't a normal incinerator that creates smoke and ash. Instead, the waste is heated in an oxygen-free chamber using microwaves. Because there is no oxygen, the trash doesn't burn in the traditional sense. Instead, it chemically breaks down into a synthetic gas called syngas. This syngas is then fed back into the ship's internal power grid to provide electricity for the hotel facilities. Yes, you heard that right. The banana peel you threw away at the buffet and the leftovers from your morning bathroom visit are quite literally helping to power the chandelier in the ballroom. It is the ultimate form of recycling, turning the inevitable byproduct of human existence into the energy needed to keep the party going. For the pollutants that can't be turned into gas, like sulfur from the fuel, the ship uses scrubbers, essentially giant seawater showers in the chimneys that wash 98% of the sulfur dioxide out of the smoke before it ever reaches the atmosphere. The result is a ship that produces water cleaner than what it pumps in and air cleaner than what it breathes out. We have looked at the steel, the engines, the physics of not tipping over, and the secret metabolism that keeps the city alive. But all of this technology is useless without the most complex component of all, the humans. How do you coordinate 3,000 crew members from 80 different countries to make sure the 600 million euro miracle doesn't end up as a cautionary tale? We've spent this journey looking at steel, bubbles, and 7,000 washing machines worth of power. But let me ask you, if we have all this machinery but no people, what do we actually have? A very expensive, very buoyant sculpture. To truly understand these giants, we have to look at the citizens of this floating state. At any given moment, a ship like the Icon class isn't just carrying passengers, it's sustaining a population of nearly 10,000 people. That is more than the population of many towns you've driven through without a second thought. But here's the difference. Your town doesn't have to worry about floating on a 9-meter basement while generating its own oxygen. Now, you might think you're just on a vacation, but legally, you have entered a sovereign, self-sufficient municipality, and a city of 10,000 people needs more than just a good buffet. Tell me, what happens when someone decides that all you can eat also means all laws are optional? Or when nature, in its infinite wisdom, decides someone's time is up in the middle of the Atlantic? By law, these ships must be prepared for the full spectrum of the human experience. Hidden away from the glittering atriums is a functional prison known as the Brig and a morgue. Yes, while you are deciding between the chocolate fondant and the fruit tart, there is a specialized security force in a climate-controlled room for those who didn't quite make it to the next port. It's a sobering thought. You're lounging on a miracle of engineering that is legally required to be a floating cemetery and a floating jail at the same time. So, the next time you see a tiny white speck on the horizon, don't just see a boat. You are looking at a floating skyscraper that refuses to obey the laws of common sense. Remember that it is a city that breathes air bubbles to stay slippery, a 250,000-ton mountain of steel that dances on a draft no deeper than a 3-story house. We've seen how they're built upside down, how they turn trash into the very light you use to read your menu, and how they use airplane wings under the water to keep your soup in its bowl. It is quite literally the most complex machine humans have ever put into the water. But I have to know, be honest with me, which fact surprised you more? That your luxury cruise has a legally mandated morgue, or that there's a prison cell right under your favorite buffet? Write Team Morgue or Team Brig in the comments. I want to see which side of ship life haunts your dreams more. If you found this dive into the secret metabolism of these ocean giants fascinating, you know the drill. Hit the subscribe button and the bell icon. We have many more engineering miracles to deconstruct, and you won't want to miss the next one. Let's head to the I-95 corridor for a drink, or the Brig, wherever the video takes us. See you in the next discovery.